Hey all, our next chapter is on transformations. And so the first transformation that we are going to deal with is called a translation. So a translation means taking a figure or a line and moving it along the coordinate plane. And so it's going to face the same direction, it's going to be the same shape, same size. The coordinate notation for translating something looks like this. So we start with x, y, and then there's an arrow. So x, y are your original points of where you were. And then we move it a distance of a units horizontally and a distance of b units vertically. So the x plus a and y plus b is where we end up. So to illustrate this, it says figure ABCD has the vertices, and all of those are listed out. I'm going to go ahead and plot those. So over 1 up 2 is A, over 3 and up 3 is B, over 4 and down 1 is C, and over 1 and down 2 is D. And I'm going to draw the lines to connect all of those. Use your straight edge here, folks. It says sketch ABCD and its image after the translation XY, x minus 4y plus 2. Okay, so a couple of things that we can do. This means, this x minus 4 means that we're moving left 4, and the y plus 2 means up 2. So we could take point A and count 1, 2, 3, 4, and then up 2, 1, 2, and I'm going to label that A prime when I draw that. That's the second iteration of that A and A prime. So that's one way to do it. You can count all your points left, 4, up 2. The other way is to use this coordinate notation and to plug in those point values. So if I do 1 minus 4, I get that A prime would be at negative 3. And then I would do 2 plus 2, and I would get that the y coordinate should be 4. So if you check, I get 1, 2, 3, 1, 2, 3, 4. It is really where it's supposed to be. So you could do the same thing with your other values here. So 3 minus 4 for B prime would be negative 1, and 3 plus 2 would be 5. For C prime, 4 minus 4 would be 0, and then negative 1 plus 2 would be 1. For D prime, 1 minus 4 would be negative 3, and then negative 2 plus 2 would be 0. So if I plot the rest of these points, left 1, up 5, don't move left or right, move up 1, and then left 3, and don't move up or down, I should get the same shape. And I've dashed that to show that it's the image. It's the polygon after the translation. So image means after the translation. Pre-image is where we started. Okay, so it says, describe each translation using coordinate notation. Every point moves right 10 units and up 5 units. So we always start with our original point of x, y. That means it can represent anything. So x, y, and then if we move to the right 10, that's taking x and adding 10, and that's taking y and adding 5. Every point moves left 3 units and down 4 units. So we start with x, y, and left 3 means we're going to subtract 3, And down 4 means we're going to subtract 4 from y. Every point moves up 2 units. So we start with xy again. Now, it doesn't tell us to move left or right. So that means we're going to have x plus 0 or just x. And then we're going to move up 2 units. So y plus 2 is up 2 units. Okay, so I kind of mentioned this before. A translation is an isometry. An isometry means that it's the same shape and size. So if you look, triangle ABC is congruent to triangle A prime, B prime, C prime. Just because we've moved it, the size and shape has not changed. Okay, so write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. Then verify that the transformation is an isometry. So our rule is just going to be, how did we move? So our coordinate notation, so x, y goes to, and so probably the easiest thing is just to pick a point. If I pick point A, how do I move to get to point A prime? It looks like I've moved 1, 2, 3 boxes over to the left. So that means I'm going to have to subtract 3. And then I've moved 1, 2 boxes up. So that means I'm going to add 2. So there's my rule. Now, we want to verify that it's an isometry. So to do that, I'm going to verify that all of the sides are the same length. So that typically would mean that we have to do distance formula 6 times. But I noticed that AC is a vertical line, and so I can just count those boxes, and AC has a length of 3. A prime, C prime also has a length of 3. I also noticed that BC is a horizontal line, so I can count those boxes. That has a length of 2, and B prime, C prime has a length of 2. So that means the only thing we have to do is figure out the length of AB and make sure it's the same length as A prime, B prime. So I'm going to, let's see, 1, 2, 3, 1, 2. So A is at 3, 2, and B is at 1, 2, 3, 4, 1, 2, 3, 4, 5, negative 1. So subtract your x values. So I have 3 minus 5, quantity squared, and then I have 2 minus a negative 1, quantity squared. 3 minus 5 is negative 2, and 2 minus a negative 1 is 3. So 2 squared is 4, or negative 2 squared is positive 4, 3 squared is 9. So I get a length of radical 13. That's okay, we're just comparing. So now let's check A prime, B prime. So I need to find those points now. So A prime is at 1, 2, 3, 4, 0, 4. And B prime is at 1, 2, 1. So 2, 1. So I'm going to subtract the x value, so 2 minus 0, quantity squared, and then 1 minus 4, quantity squared. So I get 2 minus 0 is 2 squared, and then 1 minus 4 is negative 3 squared. So 2 squared is 4, negative 3 squared is 9, 4 plus 9 is 13. So they match, therefore we can say that triangle ABC is congruent to triangle A prime, B prime, C prime. And then thus they're an isometry. Alright, if you have any questions, come see me. If not, I'll see you in class.